method called naive. So, ano siya? So, it's just since it's naive, so the forecast tomorrow is the observed data now, right? You use the present observation as the forecast value for the next time step, correct? So, yun yung naive, no? Gamitin lang natin yung ano yung present to forecast the next time. Tama? Okay. So, we also discussed several other methods such as the moving average. So, yung moving average, yung na-discuss natin, yung sinasabi mo, yung you have the...
moving average dito.
Oh, yes. Yung you use several values in the past or now and in the past. You use several values, maybe you average them to predict the to make forecast, or you can also use the yung based on seasonality, yung kung ano yung season ngayon, ano yung observation ng the same season for this year. Yeah. And then we also learn about the different characteristic na time series. Okay, so ano yung mga time series na mention ko, yung isa is yung seasonality. Tapos yung isa naman ay yung
trend. Ay, ba ito? Trend, seasonality.
Trend, correct. So ano yung trend?
Makita nimo ang kung naay increase or increase sa
correct. Very good. That's actually trend just tells you whether it's increasing or decreasing, no? Seasonality tells you whether yung pattern ba yon is nagre-repeat siya for a regular time period siya. Ano naman yung cycle? Cycle. Yun din yung kaibahan niya doon sa seasonality is that yung seasonality, it actually it repeats at a regular period, no? Balik-balik siya. For example, yung seasonality of, let us say, due to for example, yung ice cream, okay? Purchase of ice cream or revenue from selling ice cream. So makita natin na yung mga hotter months, mataas yung sales ng ice cream. Doon naman sa mga cold months is maliit. And it actually repeats every for that specific time period. Yes. And then we also discuss about how do we measure the compute the fitted values. Tama? So kung meron tayong the errors, okay? So ano yung mga errors na discuss natin? Yung mean absolute errors, mean errors, mean sum of squares of errors. Then we also have a mean absolute percentage error. Then we have the UTLE statistics. So yung mga methods na yun yung kumbaga how well does the model fit the data. Diba? And then after that, na-discuss natin, so maraming mga consideration, how do we measure the performance. We also deal with the time series decomposition. Okay? So time series decomposition is not actually in the strictest sense, it's not actually a forecasting method. It's more of analyzing the time series. Okay? Analyzing the characteristic of the time series. So if we know the characteristic, then we can use that characteristic to actually make forecasts, correct? Yes. So ngayon, let us now go to a forecasting technique. It's a forecasting technique, but it's also a way to fit the model to the data. And this can be very useful ngayon sa COVID na yun. Ngayon sa COVID, yung nangyayari ngayon, can we use exponential smoothing to predict the number of cases for the next, let us say, months? Parang gano'n. Or can we use exponential smoothing to predict the number of people hospitalized due to COVID, or the number of can we predict as well the demand for certain commodity during COVID. So we will use the exponential smoothing. Okay, just tell me kung ano, lampas na ako sa time para maka-stop tayo. Okay. Okay, so what are the learning outcomes? Well, one of the learning outcomes that we want to achieve in this lecture is a deeper understanding of exponential smoothing. Then we are also going to compute examples. We are going to use exponential smoothing on data to fit the model and also to make forecasts. Okay. So yan lang naman ang gagawin. So we have the topics, learning activity, learning outcomes, activity, and then value. Okay, so what is exponential smoothing as a briefer? So exponential smoothing was proposed in 1950s, no? Panahon to ng mama ni ID, pinanganak. Tama ba? No? Tapos, the idea is the same actually sa moving average. Okay? So weighted averages of past observation. However, the weights decay. So pag sabing decay, na ibig sabihin, it becomes smaller. Okay? Exponentially as the observations get older. So yun yung idea actually ng exponential smoothing. Of course, yung mga ginamit natin na weighting method, ang exponential kasi na-under siya sa yung weighting methods. Okay? Kasi nga, it assigns weight to observations. However, ito sa exponential, yung term na exponential, it actually refers to the idea that the weights decay, so it becomes smaller exponentially. So ano yung ibig sabihin? We are going to dissect that. We are going to analyze that. Okay? So ito na, yung more recent observation receive higher weights. Means that pag sinabing weights, ano ibig sabihin implication ng weight? Ang implication ng weight, you actually give it importance. More ang importance niya, mas mataas ang weight. Less ang importance niya, less ang weight. Okay? And then we're going also to discuss 3, which is the simple exponential smoothing, the simplest, but the most important. Why? Because it forms the basis for the other methods. Then we're going to discuss the trend methods and my most favorite exponential, which is the hot winters seasonal method. Okay. So let's go to exponential smoothing. Simple exponential smoothing. So what is the simple exponential smoothing? Okay. So review muna tayo. And kailan ba useful ang simple exponential method? Una-una, useful siya pag walang trend or seasonal pattern and data. Okay? So kung meron ng seasonal pattern or merong trend, then simple exponential may not be an appropriate method for that. But let us review. Okay? Ito yung sinabi ko kanina, ID, naive method. Yeah? All forecasts for the future are equal to the last observed value. Kamo? So ano yung magiging forecast ko in the next 3 days, in the next week, in the next 7 days? It's just the present. That's why it's called naive. Mga, di ba pag sinabi natin naive, walang alam, walang information. Yeah? Kaya ito, naive siya because walang information. Gagamitin na natin kung ano yung ma-observe mo yan as our forecast. Okay, and then we have also the method that we learned. This is the simple average. So ano naman idea ng simple average? So the idea is just to get the average of all the data points. Na? So ano yung magiging forecast natin next? For example, I have a data since last week. Okay? Starting last week. Ano yung magiging forecast ko tomorrow? So I have already 7 observed points. So ano yung magiging forecast ko tomorrow? It's just the average of those values. correct? Simple average, you add them, divide by the number of observations, and that would be my forecast. Okay? So both naive method and simple average actually can be considered as weighted methods. Bakit kaya? Sige, I want answers from you. Why do you think that both naive method and simple average can be considered as weighted methods?
Sir,
Can you,
nag-green ang screen. Oh,
huh?
okay na. Ay, nag-green ang screen.
So may I ask Mia? Mia, are you there? Parang wala si Mia.
Hi, sir.
Okay, Mia, why? Ay,
Wala ko
wala.
sa, for explain sa weighted.
Okay, ang weighted is you are actually weighting the observations. Okay? So for example, pag sinabi nating moving average, so you give weights. So actually, ang idea is kung isa-sum natin siya or i-divide natin siya, each observations will get a certain weight, hindi yung actual value lang. Tama? Kuha ba? So, bakit kaya sinabi ko dito na ang naive and simple average can be considered weighted? Because first, for naive method, ano ang weight? It's just putting all the weights on the present. Tama? Yes. Sa simple average, ano ang weight?
Yung average ng
It's just the equal weights lahat. Tama?
Yes.
Equal weight. Actually, this is the same as multiplying these observations by this weight and adding them. Correct? So that's why both of these are what we call weighted methods. So let's review why naive method is a naive method is a weighted method. IB, why?
kay same lamang gyapon ang value sa iyang mga observed value kay equal sa weights.
Sa naive.
Pa sa naive, sir.
So lahat ng weight nasa sa current observation. The weight of the other data is 0, correct? Because we actually use the current as the forecast value, the value for the future. Tama?
Yes.
Okay. Simple average, bakit siya matawag nating weighted method ang simple average? It's because weighted pa rin siya na ang weight natin ay is same for all observations. Yeah? Okay. I hope that's clear, no? Okay, so let's go to yung sagot. Naive methods puts all the weight to the present value, where a simple average distribute the weights equally to all observations. So exponential methods give less weight to all the observations and more weight to recent observation. So ito yung magiging form niya actually. So alam niyo na itong yt is the observed value at time t. So usually this is now. And then at time t minus 1, ito yung observed value. Ang weight niya ay alpha times 1 minus alpha. Ito naman alpha. Alright? Tapos ito namang yt minus 2, ang kanyang weight naman ay alpha times 1 minus alpha square. So to continue that, ano yung magiging weight ng y sub t minus 3? It's just alpha times 1 minus alpha raised to 3. 3 kung yt minus 3. So i-add mo lang yan, that will be your forecast at T1. So ang ibig sabihin nito, that's actually the correct means the forecasted or the estimated or the fitted value. Correct? And then this alpha here is what we call the smoothing parameter. Okay? It's a smoothing parameter and the value is between 0 and 1. Correct? Bakit? Bakit siya magandang gamitin as weight? Dapat kasi meron kasi mga magandang karakteristik na paggamit tayo ng weights, merong mga karakteristik na nice to have for weights. Ano yung isang karakteristik na yun? All the weights must sum to 1. Yes. So now, what we need to show is that if we continue this, of course, until y sub 1, no? T minus, let us say, t minus 1, or hanggang y sub 0, or the initial, then, these weights, ano kaya ang magiging sum ng mga weights na yan? Yan ang magiging tanong. So, what is the reasonable weighting? It must be sum to 1. Approximately, no? If we're going to use all the data, the weights must approach or must be approximately equal to 1. And of course, the recent observation has more weight compared to the previous. Alam natin ito, if alpha here is between 0 to 1, we know that alpha is greater than alpha times 1 minus a kasi ang alpha natin ay between 0 and 1. So let us say 0.3 ang alpha. Tama? So kung 0.3 ang alpha, ano mangyari dyan? Okay, stop. Kaya ko muna. I will open a Jamboard para makapakita ako sa inyo ng mga drawing. Solving.